Hello and welcome everybody. Today is the day 10 of our Smart 25 Days challenge, and today we are going to make a simple auction smart contract. This smart contract will allow a person called as the auctioneer to register himself in the auction for, and we would be requiring some details from him that what is the thing which he wants to auction, and along with it, for how much time the auction would be happening. That is the duration for the auction, and a base price at which the auctioneer wants to keep the product which he or she wants to auction. Okay, and we would be allowing anyone to participate in this auction. And as we are using this whole in a decentralized manner, this will increase the transparency and it will avoid any conflicts. So we are going to make it, and I will be taking you forward and teaching you step by step how we can make an auction smart contract. So just stay with me. So these things you must be by now very familiar with these terms. These the first line is the SPDX license identifier, and then you specify the version. Okay, and now let's start building our smart contract. Let's call this auction only. Okay, looks good. Auction. Then so first step would be that we would be declaring the state variables, and the state variables here would be the address of the auctioneer. Yeah. Then along with it, we'll see what he wants to sell. So we'll ask him about the item, and let's declare a uint. And I have told you before also that uint 256 and uint are the same things. For detail, please watch my previous videos. So let's call this uint only. Uint public auction and time. Or for details, let's keep it uint 256 only. Auction and time. Okay. So this would be the auction and time that the user, the auctioneer, would be providing us. Then one more thing we need is the base price. Base price. Now let us declare something that how we are going to keep track of the highest bid. Okay, so we need to keep track of the highest bid, which is what would be the current bid, which is at the highest, so other users can see it and then make their bids accordingly. So let's, and we also want to make sure that the users know about the bidder who is. Okay, so address or public, and we can call this the highest bid user, or just say, let's say, just simply highest bidder. Highest bidder. Okay, highest bidder. Then the bid. Okay, which she has made highest bid. And we also need to keep track that so currently we, as we are specifying the state variables, so we also need one more state variable that would be to keep track whether this auction has ended or not. So let's make a boolean flag that would be ended. Let's call this ended only. Okay, so after this, what we require here is that we would be following a simple principle that would be that each user would be placing for a bid. Okay, and if his or her bid gets surpassed by some other bidder, so the previous bid would get would be added to a mapping called the pending returns or something like previous bids. So this mapping will help us to give back the amounts to all the previous bidders. So what will happen is, if say someone places a bet of 3 ETH and some other guy places a bet of 3 ETH. So what happens is, and some other guys places for 5 ETH and some other guy places for 7 ETH. Okay. So what will happen is, at the last, the 7 is the highest bid. Okay. So all the previous ones whose bid was not the highest ones would be get added to this mapping, and this mapping will help us will help the users to get back their funds. So when they would wanna withdraw their funds, they can just call the withdraw function. We would be making a function called withdraw, and then by the help of this mapping, they can get their funds back. So this will avoid any kind of confusion. And what will happen is, the highest bidders amount will get transferred to the auctioneer's account. So what will happen is, the transaction will get complete. Okay, after ending when the auction will get ended, so the highest bidders, the bid amount would get transferred to the auctioneer's bank account, and all the others can withdraw their funds. Okay, so that's what we are trying to do. So let's call this mapping uh, pending returns, or we can also call it previous bids. So let's call it pending returns only. And the mapping will associate the addresses with some uint 256, and that uint 256 is basically the amount. Okay, the amount which the users who want to participate in this auction would be sending to this smart contract. Okay, so public pending returns. We would also be using some events in this. So as I have already told you what are the events in the previous video, so we would be using them here. Highest bid increased. The event would be that the highest bid has now increased. So address bidder and the amount. Okay. Amount. Auction ended. To tell everyone that the auction has ended. Auction ended, and we'll announcing the winner who won and what was the bid amount. Okay, looks fine to me. So these would be our events. So now let us start making some functions and constructors. So what is a constructor? I have told you this is a special function which gets executed only at the time when the contract is being deployed. So this constructor will take some arguments. It is asking, the parameters would be item. Okay, 6 duration. Okay, and we'll take the duration in minutes. You can take it in days also, but uh, for this specific implementation, we are taking it in minutes. 6 now duration, and then let's know the base price. Okay, base price, and we are taking this base price in Ethereum. ETH. Base price in ETH. Okay. Auctioneer. So auctioneer would be the message dot sender. The person deploying this smart contract would be the auctioneer. Okay. So and the item would be here we are taking a parameter called underscore item, and then we are assigning this to the state variable the value that the user will provide us of this item. So item would be item, and then auction. Okay, so when we are specifying these are called parameters. Okay, and when the user enters some value in them and sends them, so then they are known as arguments. So I know most of you must be knowing this, but just to make it clear, I have just told you this. Auction and time would be block dot timestamp plus duration in minutes into 1 minute. 1 minute. Okay. So this minutes is a keyword which Solidity provides us, like days. So there are minutes also, and there are seconds also. So base price equals to base price in ETH into 1 ether. Okay, looks good to me. So the constructor function is now complete. Now let us make some modifiers. Let's make the use of modifiers also. Engineer. So what are modifiers? I have told you in detail in my previous videos. You can also go through the notes which I would be providing with this video. I provide with every video the notes also. Okay, so you can go through them. In the previous days, I have explained in detail. So this will help us to reduce the redundancy. Okay, so let's make it only auctioneer. So for these functions which would be called only by the auctioneer, we would apply this modifier to them, and the condition would auctioneer. Okay, so otherwise only only the auctioneer can perform this task. Okay, looks good. So and now the underscore. Okay, and that's it for the only auctioneer modifier. Let's make another modifier called as only before end. So that means that only before the ending of this auction, these functions would be called. Okay, see, so the functions in which we want that they should be called only before the auction has ended. Okay, so after the auction has ended, they should not be called. So in those functions, we would be using this modifier only before end, and the condition for them would be, yes, we'll first check that whether the ended flag is already true. Okay. If it's already ended, then we'll say that auction has already ended. And the other required condition would be that the blocked of timestamp should be less than the auction time. Okay. Less than the auction end time. Otherwise, we'll say that the auction time has, oh yeah, auction has ended simply. Auction has ended. Simple. This only, okay. And then our best code. Oh, ended. Okay. So that's all for our only before and modify also. So now let's start making the functions. So the function would be place bid. The first function would be to make the anyone place a bid. Okay, allow anyone to place a bid. It's payable because we want the smart contract to receive some funds through this function. Okay, if you are feeling this that I am going a bit fast, then please I would suggest you to watch my previous videos. Then everything would be very clear because I have explained in detail in my previous videos each and everything which I am covering here or I am doing. Okay, so I would recommend watching my previous videos if you are feeling that I am going a bit fast or you are not understanding anything. The bid amount should be greater than the base price. Okay, looks good. And the required condition would be should be greater than the highest bid now. Okay, so this looks fine. So now we are also going to check that if the highest bid is not equals to zero, so then what will happen is we'll or what will happen is we are this pending returns, this mapping we have created, and we want to make sure that any person who places a bet, if his or her bet gets surpassed by the higher bet, so he should be able to withdraw his funds back. So here, what we are doing is we will make sure that if the highest bid is not equals to zero, that means that there is a if when would be the highest bid be zero, there that is only in the initial condition. Okay, when no one has placed and this guy is the first person to bid, so then only the highest bid would be zero. So we are checking that if the highest bid does not equals to zero, that means that if there is some highest bid, okay, currently there is some guy with some highest bid. Okay, so say there are three four guys, one with 2 ETH, then 3 ETH, then 4 ETH. So 4 ETH is the current highest bid. So that means that yes, the check will pass and the condition will be true. And what will happen is we want that because see, here we have checked that the new person who is making a bid, his bid should be greater than the highest bid. What it means is itself that the current highest bid is going to be surpassed by this person who is calling this place bid function. Because only when the value passed value which he would be sending to this smart contract, the value for which he would be placing the bet, or the value which he wants to give in this auction should definitely be greater than the highest bid. Then only he would be able to call this place bid function. So what is happening is when this guy calls the place bid function, it makes sure it is already clear that now the highest bid is not the current highest bid, and it is going to be replaced by some other highest bid. So what we are checking is this condition is just for the first time. Okay, if the highest bid is does not equals to zero. Okay, if the highest bid is zero, then we this condition would not be checked. Otherwise, if there is some highest bid currently, what will happen is turns the address of the highest bidder. Okay, HIG highest bidder, uh, in its address, the his bid amount. Okay, the current bid, highest bid would get added. So what is happening is, see, this mapping we have created, this associates the addresses with some UN256 value, and those this UN256 value is nothing but the value which the for which the person has made the bid. Okay, so what will happen is in this line we are saying that we are accessing the pending returns, this mapping with the key is the address, that is the highest bidder, current highest bidder. Okay, so say some guy was the highest bidder with 4 ETH. Okay, so this guy is currently the highest bidder, and some other guy now comes and he wants to place a bid with 6 ETH. So what will happen is we are making sure that the highest bidder, okay, his address, okay, the highest bidder's address is mapped with, we are, what we are doing here is we are adding the value u into 56, this value. Okay, this is the key and this is the value. What we are doing is we are making sure that the highest bid, that amount which was his amount. Okay, his amount was say 4 ETH only, just now I told you. So this 4 ETH gets stored, they gets associated with the address of that highest bidder, and this 256 unit 256 is the value, that highest bid. Because what is going to happen is this highest bid is now going to be changed, and this highest bid is now going to be made the highest bid by the message dot sender of this function who is calling this function. And then highest bidder is also, oh sorry, that this is the highest bidder. Okay, and message dot sender, and highest bid is going to be the message dot value. And then we'll emit the event called highest bid increased. Bidder is message dot sender, the value is message dot value amount. I hope I am very clear, as I have tried my best to explain this. If anyone did not understood it, so for them I am explaining it. If you have you have got what I tried to just explain, then you can skip this part. So one more time, I am going to repeat. What is happening here is, say some guy, initially the auction, the bid the no one has placed the bid, so highest bid was zero only. So what will happen is someone comes and places a bid for 2 ETH. Say someone comes, the base price was 1 ETH only, and the guy comes and wants to place a bid for 2 ETH. So that guy will come and call this function place bid. And this place bid function, the required condition would be the message dot value should be greater than the base price. Okay, the base price was 1 ETH and he has now placed the bid for 2 ETH, that is fulfilling this condition. And the message dot value should be should be greater than the highest bid. So clearly the highest bid, the message dot value is greater than the highest bid, as currently in this scenario the highest bid was 0. Now, what happens is this guy places the bid of 2 and he becomes the highest bidder as of now. Okay, so this condition will not be true because the highest bid is 0, is not 0. Okay, so is this condition is checking whether the highest bid is not 0. But in our case, when the first person comes, the highest bid was 0. So what will happen is this condition would be skipped, and the person placing the first bid would become the highest bidder for that very moment, and the highest bid would be his value. Okay, his value is here 2 ETH, and we'll just emit this event. So what will happen is, there now some other person comes, the person number 2 comes, and now he wants to place a bid for 3 ETH. What will happen is that these conditions would be checked. Yes, the message dot value is greater than base price, which was 1 ETH, and message dot value is greater than the highest bid, which was for this very scenario. When the 3 ETH person is calling this function place bid, the person who wants to place the bid of 3 ETH, when this that person is calling this function place bid, at that very moment the highest bid is of 2 ETH. So what will happen is that yes, this condition will also fulfill to be true, that yes, the message dot value is greater than the highest bid. So now this condition, he will fall in this condition, because now at the moment the highest bid is 2, not that condition is, yes, that condition is not 0. So this condition is true, that yes, the highest bid, it does not equals to 0. Okay, the highest bid is 2. And what will happen is, we are saying that now the highest bidder should get into this mapping pending returns, because what is going to happen is Now, if these two conditions are being fulfilled, that is definitely sure that now the new highest bid has been made. And so, this guy who had earlier made the highest bid, that was the guy with who placed the bid for 2 ETH, is now should be sent to this pending returns mapping so that he can withdraw his funds, because now he is not going to be the winner because his bid has been surpassed. So for that, so this continues. So after the person, some person can, another person can come and make a bid for 4 ETH. Another person can make the bid for 5 ETH. So the same manner, this will continue. But this condition will make sure that the everyone whose bid is not the highest gets added to this pending returns mapping, and this function updates the highest bidder. I hope I am very much clear, but still, if you guys have any confusion, then please ask me out in the comment section. Thank you. And now let us move on with our another function, that would be to withdraw. Withdraw. Okay. For which we have created this mapping so that the person would be able to withdraw withdraw his funds easily. So 6 amount is, what is the amount would be the value associated with that address which wants to get its funds back, and then returns message dot sender. Okay, looks good to me. And if amount is greater than 0, then what will happen is that say amount is greater than 0, what will happen is pending returns message dot sender. So what is happening is, when the amount which the user wants to withdraw is greater than 0, so we are making the amount, we are updating that to 0, because we know that this guy wants to withdraw, and so that he should not be able to withdraw the funds again and again. So if the amount is greater than 0, if it's 0, then it's no problem. But if it's greater than 0, so we want to update that address, update the value associated with that address. Okay, so this u into 56 value to 0. Okay, so, and after this, second, in this condition only, if sender send So what is happening in this function is, so this function is for the withdrawal of the funds or the unsuccessful bids. Okay, so the bidders whose bids were lower, who could not win, would be able to withdraw their funds. And what is happening here is, this line first of all retrieves the amount, okay, the amount associated with each bidder, because we have created a pending returns mapping, as I've told you before. And the key is the address, and the value is a UN 256 value, and that is the amount. Okay. So what happens is, it then this condition checks that if the amount which the value retrieved in this line is greater than zero, then we'll set the pending returns message or sender to zero. That means that we are now updating the value associated with that address to be zero. So because the user is just now going to withdraw his funds, so we are going to make sure that he may not withdraw the funds again and again, so we are making it zero. And then this line, if well, msc.sender.send amount, so what this line is doing is, this line is trying to transfer the amount, okay, this amount to the message.sender. And when it's trying to do so, what is going to happen is, if it gets successful, okay, so this value would be true and the not of it would be false. So this condition would not be checked, and this return true will means that this withdraw function successfully got executed, and because it returns a boolean variable, true or false. So in case the transaction was not successful, what will happen is, this payable message.sender.send amount would return the value false, and this false with the help of this not will become true, and then this if condition would be checked. And then what will happen in this code, what we are doing is that these pending returns message.sender, then we are reassigning that original value, okay, that original value was this amount only. Okay, so we are reassigning that amount with the, we are associating that amount with the address again, and returning false, that the transaction or did not execute successfully, and the value of the boolean would be false. So that's what this withdraw function is doing. And now let us make a function to know how much time is left for the auction to get over. Get time left. Let's call this time left only. Mm, 256. If not dot timestamp is less than auction end time. Okay. Because if it's true that yes, the block dot timestamp is less than the auction end time, then we'll just return the value of auction end time minus block dot timestamp. Timestamp not actually. Okay, so this function what is, and we'll say one more thing, that is the else part. That is, if the block dot timestamp has passed the auction end time, we'll just return that the time left over is zero. So I have not closed this function. This function is not closed. Okay, so this line, this return true will come here. Looks like yes. Should work properly. Okay, this should work correctly. And let us see what is remaining now. Okay, so let's now just make our final function, that would be to end the auction, public only auctioneer. It should not have ended. Means it should not have already ended. Okay. So, and block dot timestamp should have passed the auction end time. Otherwise, we'll say that auction end time has not passed. Otherwise, what the auctioneer can be biased and he may decide to close this auction beforehand. Okay. And after this, we'll make the ended as true. Then emit the function called auction ended. The winner is the highest bidder. Highest bidder. And the amount would be the highest bid. That's it. And when this end auction is called, the auctioneer will get the amount. That amount would be the highest bid. Okay. Let's see the highest bid. That's it. So now our auction smart contract is complete and now we can play with it. Now let us test it out. So let us try to deploy it. Okay. So say this person wants to deploy it with unless in United Kingdom. Duration say let us say 2 minutes and base price let us say 2 ETH. So let's deploy it. Okay. So currently you can see the balance of the smart contract is 0 and let us see the highest bid. It's 0 and highest bidder is no one. Okay, so let us say this guy wants to bid for 1 ETH. Let us see what will happen if he tries to do so. So he wants and tries to place a bid. What is happening is the bid amount should be greater than the base price. Completely makes sense. So now let us say he wants to place a bid for 3 ETH. So yes, he's allowed to place a bid for 3 ETH. Someone. So now let us check who is the highest bidder. So that guy only, CB2. Okay, this guy CB2 is now the highest bidder as of now. And say this some other person comes and he wants to place a bid for 4 ETH. Say okay. So let us see what will happen. Okay, the balance of the smart contract becomes 7 and the highest bidder gets changed with the address of this guy and the highest bid also gets changed and let us see how much time is left. Okay, so say 44 seconds are left. So some other guy comes and he wants to place a bid for 7th, let us say, and he tries to place a bid and okay, what will happen is the highest bid will get changed. If some other guy comes and he tries to bid for say 3, say, let us see what will happen. He would not be allowed. The bid amount is too low. Okay, let us see how much time is left. 14, 13. Okay, so just 10 seconds left. So here you can know the about the item. Okay, so after the time has passed, now the owner can now end the auction, and the amount of 7 ETH, okay, which was the highest bid, will get transferred to the auctioneer's account. So let us try to do so. So let us say try with some other account. Okay, let us try with this person's account only. And he calls the end auction function. What will happen is only the auctioneer can perform this task. Okay, makes sense. So this guy was the auctioneer. Okay, so this will want to end the auction. So 7 ETH will get transferred to his account. So yes, you can see, and he has got 7 ETH. What about the other ones? These guys can now withdraw their funds. So this guy withdrew his funds, and now he got all his funds back. Yeah. Let us say this guy tries. He also got. So this will not get because he won the bid. Okay. So that's all in this smart contract for you guys. And I hope you learned something from this smart contract. I have a task for you guys, and I would be very happy if you are able to perform it. So in this smart contract, what is happening is the if say the same person, this person wanted to change his bid. He wanted to increase his bid. So the scenario in this smart contract is that he can withdraw his funds, but for say he placed a bid of 2 ETH and some other guy placed a bid of 3 ETH. So the first guy who placed the bid of 2 ETH wants to increase the bid uh, and make it 4 ETH. So in this smart contract, he would be required either to send all the 4 ETH in the value. Okay, so technically he would need to block 6 ETH at a time for placing a bid for increasing his bid from 2 ETH to 4 ETH. But in the ideal case, it should be something like he should only be willing, he should have allowed to send only 2 more ETH the uh, to make the amount as 4 ETH. Okay, so to increase his bid, he would have been required just 2 more ETH. But in this smart contract, what is happening is he would be required either to send 4 ETH. Okay, or the other case could be that he can first withdraw his funds. Okay, so he can first withdraw his funds, those 2 ETHs which he had first of all blocked. He can withdraw them and then send a transaction of 4 ETH. Okay, so in that technically he would need to only spend 4 ETH, and that should be the ideal case. But if he does not want to first withdraw, because see the thing is it increases the task of the user. The user will not be willing to first withdraw the old funds and then increase then send the another funds. It would be easier for the user if he would have been given some option, if he would have got some option using which he would have been able to increase his bid. Okay, so to increase means ki if the old bid was of 2 ETH, so he would just be required to send 2 more ETH to make the bid as 4 ETH. And that is the ideal case. But in this smart contract, that is not happening. What will happen is if the user, so let me just give you a practical demo of what I'm trying to say. Okay, so in this smart contract, what will happen is, let us try to deploy it. Okay, let us make this base price say 1, duration also say only 1 minute. Okay, and now let us try to transact. Okay, deploy it. So what will happen in this is, what I'm trying to say is, this person, say one person comes and he wants to place a bid of 2 ETH. Okay, so he tries to place a bid of 2 ETH. Some other person, this person comes and he places a bid of 3 ETH. So what will happen is the second person will become the highest bidder with 3 ETH. But our first guy has uh, already sent a transaction of 2 ETH, and he should now be able to just increase his funds, or to make the bid as 4 ETH. He should be able to just send a value of 2 ETH here, and then his bid should have been made as 4 ETH, but it's showing that bid amount is too low. What is happening is he can either first withdraw his funds, and then what will happen is he can send the transaction of 4 ETH altogether. Otherwise, what will be required is, without withdrawing, he would need to altogether submit 4 ETH here, and that would technically mean that at one particular time, although he will get the funds which would be coming into the pending returns, this mapping, although he would get them back, but technically at one point of time his 6 ETH would be stuck in this smart contract, and that is not the ideal case scenario, and I want you all to find a solution for this and implement in this smart contract. And if you guys are able to solve it, then it's well and good. Otherwise, I would be providing the solution into the notes of this, of this smart contract, okay, into the notes. And I hope you have understood my problem. If you have any confusion regarding the problem statement, then please ask me out in the comment section. You can also connect with me on LinkedIn and Twitter. You can ask me your doubts there also. And if you have understood my problem statement, then please try to find a solution for that. And I hope you learned something from this video. So we'll meet on the day 11. Okay. So bye bye.